Hello, this is Mrs. Sturgeon here to explain how to solve a system of equations using the elimination method. So let's go ahead and get started. In order to do elimination, let's think about what the word eliminate means, right? Eliminate means to get rid of something. Okay, so when you're solving a system of equations using elimination, your first goal is to eliminate one of the variables. Now, how do you do that? All you do is you put a big old plus sign over here and you essentially add each of the variables like terms and see what happens. Okay, so for the first variable here, we've got x's. We've got negative 2x plus 2x. So I'm just going to play this out and kind of show where this is going to take us. Negative 2x plus 2x. Turns out if you add negative and positive of the same number, cancels out, it goes away, 0. Okay, so I'm going to go ahead and cross this out. Notice, if it's gone, that means it's been eliminated. Okay, so I'm already on the right track to solving a system by elimination. I've eliminated the x's. So next, I'm going to go ahead and add 3y plus negative y. Be careful, you need to make sure that this negative stays with the y. All right, so 3y plus negative y is going to get me a 2y. Okay, then if I do 4 plus negative 8, I get negative 4. So the whole purpose of solving a system by elimination is basically to solve for each variable individually and use both of those variables in your final answer. The goal is to get essentially an answer for x and an answer for y. So as of right now, since I've eliminated the x's, I'm solving for y. Okay, so I'm going to go ahead and finish by doing the algebra. Let's divide both sides by 2. Divide by 2, divide by 2, because again, anytime you have a number right next to a variable like this, that's multiplication, undo it using division. So I get, my final answer is y equals negative 2. Now, we're not done. A system of equations, we started with both x's and y's in my system. That means my answer needs to have both x's and y's. So I solved for y already. Now let's talk about how to solve for x. What you do is you take your answer for y and you substitute it or plug it back in to one of the two original equations before you actually did the elimination. Okay, so it doesn't matter which one. Some people just choose to do the first one automatically. It really does not matter. So I'm going to copy everything down, negative 2x plus 3, and then instead of writing y, that's where I'm going to do my substitution. Okay, so instead of putting y here, I'm going to put negative 2 equals a positive 4. So my goal here is to solve for x. Once I've solved for x, I finish the problem. All right, so negative 2x plus 3 times negative 2. 3 times negative 2 is negative 6. So it becomes negative 2x minus 6 equals 4. Okay, now it's just a matter of solving using algebra. So let's add 6 to both sides to undo that operation. Okay, I'm running out of space, so I'm going to come on over here. So I get negative 2x equals 4 plus 6 is 10. Last step, divide both sides by a negative 2, and you get x equals negative 5. So I've solved for x and I've solved for y. That means I finished the problem. I usually write my answer as an ordered pair, so I'm going to go ahead, x always comes first. So negative 5, comma, negative 2. That is my final answer. What that means is if I were to draw a graph of each of these two equations, they would both turn out on the graph as a linear equation or a line, and those lines would intersect at the point negative 5, negative 2. So you could graph those lines and check to see if you got the answer in the correct location, but we're not going to take the time to do that right now. Let's just do one more elimination example, and that'll be it. Okay, so for this example, let's go ahead, same thing. We're going to add the two equations together and play it out, see what happens. If I add 3x plus negative 3x, Look at that. That's the first variable that's going to be eliminated. It won't always be x that eliminates first. Sometimes it might be y. But in this case, it happens to be x. In the last example, it happened to be x as well. It depends on how the numbers work out. So again, the x's eliminate. I'm left combining like terms now. So 2y plus 4y, that's going to get us 6y. And then 7 plus 5 is equal to 12. Okay, I just have to be careful and make sure all of my math is correct. So, last step, divide both sides by 6 in order to get y by itself. So we get y is equal to 2. Next, since we're not done, I started with 2 variables. That means I have to end with 2 variables. So let's take our answer and substitute it back in for either equation. Let's just choose the second equation now, just to show that it actually does not matter which original equation you choose. So I've got negative 3x, okay, we don't know what x is, that's what we're going to be solving for, plus 4, and instead of the y, I'm going to put parentheses 2, because y is equal to 2. Okay, finish writing, so we've got equals 5. Let's go ahead and do the math. 4 times 2 is 8, so I got negative 3x plus 8 equals 5. Let's keep going. Subtract 8 from both sides. You get negative 3x equals 5 minus 8 is negative 3. The 8's on this side would have canceled out. Divide both sides by negative 3. And I'm left with x equals positive 1. So my final answer, written as an ordered pair, is 1, 2.